Invited talk. You'll be talking to us about MoonRIDERS, NASA and Hawaii's lunar surface flight experiment for late 2016.
Aloha. Thank you for having me. It's a joy to have the opportunity to come and share with you today some of the work that we're doing. The Pacific International Space Center for Exploration Systems in Hawaii is funded by the state of Hawaii to do applied research in planetary surface systems. So we do rovers, robots, drills, ISRU, planetary construction technologies, and others. But the topic today is the one that's highlighted here, which is our lunar surface flight program that we're extremely excited about and is using a very innovative business model. The flight project is called MoonRIDERS, RIDERS standing for Research Investigating Dust Expulsion Removal Systems. The goal of the flight project is to develop, launch, fly, and land to the moon, a Hawaii high school student experiment in concert of leveraging expulsion technologies, dust technologies from the NASA Kennedy Space Center as a part of an upcoming Google Lunar X Prize launch to the moon and in the early 2017 time period. So about a year and a half from now. This is our flight program, develop our logo done by the one of the high schools working with us. So you see the dust particles that's integral to the flight project. But in addition to that, it's also those dust particles are in the shape of the Hawaii Islands. So I thought that was really cool. So the big one right here is Big Island. So that's our flight project logo. Dust has been a significant issue all the way back to Apollo. We see it as an issue on Mars Exploration Rover. You see it MER covered with dust both on solar rays and the radiator. Occasionally you get a dust devil that cleans it off. It was a major issue with the scratching the gold visor in Apollo. It got all over the camera systems, including the lunar rover vehicle camera. You may remember them having to swish off the dust with a dust brush during the EVAs and on the J missions. And of course, being very attaching to the suit, it changed the thermal characteristics of the suit, where it got darker, absorbed more heat, made us use more water for cooling within the flight suit itself. So the goal here then was to establish a joint flight technology project between two Hawaii high schools, PISCES, and then the NASA Kennedy Space Center. With two objectives. NASA has been working on this technology of dust removal systems for about 4 or 5 years, but can't get to the moon. Obama's not going to the moon, so they can't get it outside the laboratory. So this innovative business model allowed the government to be able to flight test these at the lunar surface. The other reason that we're doing that is within the state of Hawaii. At the 8th grade STEM testing level, Hawaii ranks 46th. And that was great concern for me. Over the last year or so, I've been very passionate about workforce development and education within the state of Hawaii. And I wanted to involve a couple of high schools in doing something more than just throwing basketballs through hoops, and have them a part of a collaborative system engineering experiment that involves hardware and testing at the surface of the moon, something that has never happened before. There has never been a high school experiment, excuse me, on the surface of the moon. So we had twofold reason for this. One is advancing advanced exploration systems technologies for headquarters, and then secondly, using this as a gold standard for incentivizing students in Hawaii to become involved in science, technology, engineering, and math. We selected two high schools. One is in Honolulu and Oahu, a very wealthy private school, Iolani. And the other one is Kealakehi. They're represented here in the back in their blue shirts. They've got a couple of great poster sessions as well that they've been presenting over the last couple of days. Both of these schools are well-versed and well-recognized internationally in robotic competitions, FIRST Robotics. So they know how to do avionics, cut metal, build hardware, and both of them have a great pedigree in being involved in robotics. So out of the 4 demographic areas, they represent the STEM and academic piece. PISCES represents the state piece. We're the program integration manager for the flight project. The federal sector is the NASA Kennedy Space Center. They're doing the technology development for the flight. And then, of course, we're leveraging on industry commercial space as a part of the Google Lunar X Prize project. The business model here is very interesting. We've set it up where there's no money that exchanges hands. Kennedy funds the development of the hardware at the Cape through internal research and technology funds. I fund my piece, and both high schools are funding their piece to include building flight hardware for the experiment out of the 2 high schools. So no money exchanges hands. We operate under a non-reimbursable Space Act agreement, so only product and deliverables exchange hands between the 4 elements, which is very interesting because one group has to have product delivered by another group to do their next step. So it is very much a collaborative system engineering exercise with dependencies of products across the elements, but without changing hands within money. NASA is also providing mentorship to the 2 high schools in the physics of dust, issues with the dust that was seen in Apollo, the physics of the repulsion of dust on surface systems, and the like. So right now we're working an extension of the Space Act agreement with Kennedy. We have one in place and we're extending that. We're in the process of now developing a flight qualification unit that'll get it down to the ½ kilogram level. So that's all hardware and avionics within the flight project that'll fly. And so we're working now to get that all down within the ½ kilogram box, as well as doing thermal vacuum testing. We had a glass substrate for the dust shield. Kennedy's now switching to copper kapton, which actually lowers the voltage of the dust removal system from about 1,500 volts down to as low as 700 volts. We just finished a major test in March and completed the data analysis of that for the dust shield. And we're also looking at now a reduster. We're hoping to get dust during descent and landing on the shield as a part of the billowing of the dust during descent and landing. But if we don't, we want a backup method for artificially getting the regolith on the dust shield for doing the technology demonstration. So we're looking at some engineering concepts of what we call the reduster. And some of the companies that are tied with NASA headquarters Catalyst have actually come now and begun to express interest in the dust shield for camera lens applications. So we're coming back in November with a flight qualification test to look at the imaging systems and the flight configuration that we need to gather the data for the mission. We'll do that in November. And we're also beginning to work our funding for the integration of the EDS into the spacecraft. That'll be about $100K. The state of Hawaii, in a couple of different grants, has given us up to $35,000 now of that, and so we're well on our way for getting the money so we can do the engineering integration into the spacecraft. We're looking forward to doing a payload contract with the Google Lunar X Prize. That's dependent on them doing a booster contract that we hope that they're able to do sometime by the end of this year. And we're also looking at control center operations for Kennedy and the high schools. Right now we're looking at firing room 4 at the Cape as a part of the control center operation. So the kids have been involved in building the hardware, full-scale mock-ups of 2 different lander systems that we were testing out into the field. There's advanced mentoring sessions on the physics of the dust and engineering solutions for the dust shield itself, as well as a major component of this is for the high schools to go into the intermediate schools, the elementary schools, and do outreach to excite the kids into science, engineering, and math. This was a major test that we did, a 10-day test out in the field in March to look at flight configurations for the EDS as well as camera systems. This is a 12-inch landing pad, which is close to what we expect to fly on, and this is a full-scale mock-up of the dust shield. The avionics will fit within the red hash box here. We set up a gantry system and a high-velocity gas system that flowed through a nozzle to stir up the very fine particles at our Hawaii test site at various heights above the surface. That then led to deposition of the dust particles onto the EDS. After that, then it was lowered, and the team brought in the various imaging systems to characterize the dust performance on the EDS before and after repulsion. So our data acquisition systems are essentially the cameras that'll be on the lander or on the rover as a part of the flight. We're also tied in with Catalyst. Catalyst is one of Jason Crusan's projects. Nantel Suzuki out of headquarters manages it. It provides government capabilities, services, labs to 3 different groups, Astrobotic, Marsden, and Moon Express. And so we're looking at also how we can leverage through Kennedy some of those capabilities for Moonriders through the Catalyst project. This is our flight project layout of where we are. We just finished the large test in March. Just completed the analysis of that with briefing to the Google Lunar X Prize team in a couple of weeks. The high schools, as they come back in this next school year, are going to be building the new frame based upon the redesign for copper Kapton of the dust shield. That'll be in August through October. And then they will build the flight qualification frames in December that feed into the flight qualification unit built by the Cape. And then the flight frames will be built by the 2 high schools next spring that flow into the flight unit that then we deliver next September, about 14 months from now, for integration into the spacecraft with a launch hopefully in early 17. We're also looking for doing a payload contract depending on when the booster contract with a GLXP team takes place. Once that happens, we'll do a payload contract that starts the engineering integration analysis between the dust shield and the spacecraft. That'll carry through all the way into flight integration. Oh, the other interesting thing I wanted to point out to you is based upon the success and interest out of NASA, including NASA headquarters and others for Moonriders 1, there's been interest in how do we move forward into Moonriders 2 and 3 with this same business model. I should mention that back in 2010, Greg and myself, Clive Neal, met here in the Bay Area at a Google Lunar X Prize Summit with the Google teams, specifically looking at how can we use the commercial landers for hosted payload or ride-shared enabled capability for doing lunar science for Jim Green and PSD, as well as technology development. We think Moonriders is the first fallout of those discussions back in 2010. But we don't want to make this one and done. So we're actually having some discussions with Japan and JAXA. I met with them in October. I'm back over there in September, talking with them on how we can use the same business model for the smart lander investigating Moon. This is a 120 kilogram lander that they plan to fly in 2018, or also opportunities to fly on Selene RP. So the opportunity here now is to put a U.S. university and a Japanese university working together in a collaborative engineering environment that down selects technology to be flown to the surface and tested out of the JAXA roadmap and the LEAD roadmap. So this is how this ties in, hopefully in October in Maryland with the LEAD meeting. In addition to that, China's come and approached us with opportunities to fly on Chang'e 4. Chang'e 4 is the backup flight set that went to the moon in December of 13, that they plan to refly in 19. India's come to talk to us about the same thing, and now we're looking at opportunities with Russia, putting a Russia university and an American university together that could fly on one of the Russia landers. So the concept here is, how do we leverage these, since NASA's not putting a lander down on the moon, how can we leverage not only the commercial landers but also the international lander platforms for enabled science and enabled technology test beds on the surface of the moon. And so with that, we're very excited about this flight opportunity. It's going extremely well. You know, the big holdup now, the next step is waiting for the booster contract between the Google Lunar X Prize team, so we can establish the payload contract for getting the dust shield beginning its integration process into the spacecraft. With that, I'll take any questions. Thanks for letting me come and be with you here today.
We have time for a few questions. And maybe while people are thinking of questions, I'll take the opportunity to ask the first one. And so you actually spoke about reduster. And if I remember right, watching the onboard cameras from Apollo landings, you know, the rocket plume would initially get rid of the small fine-grained materials, it'd be blasted away, and then it would start removing larger pebbles and then break away some crusts and whatnot. How do you envision being able to get dust onto the experiments if there's no dust left?
Yeah, so great question. So right now we're hoping that we get reflections from aerolifted from the engine off the base plate of the lander and deflected down onto the dust shield. In case we don't get enough, we're looking at some engineering solutions on how we can artificially get some of the regolith casted up onto the EDS so that we can effectively test that technology. So we're opening it up for ideas. We're interested in ideas on some innovative engineering solutions for a backup method for dust deposition for flight.
Hi, Carl Hibbets, APL. I'm sure everybody here wishes you the best of success. This is a wonderful project. I used to be at University of Hawaii as a grad student, so it's great to see work going on there. So I have a question about how it's implemented. I'll hear a little bit about how one would ensure success with interfaces between these very disparate organizations at, like a high school and NASA. How does one do interface control documents if such a thing exists? And also, when working with high school students, how do you ensure they use electronics and practices quality control that will work? And do you use space qualified electronics to ensure success, or can you get away with, you know, Cat 2 or 3?
Great question. So we're using standard NASA documentation out of Kennedy that controls the overall flight architecture and integration. Kennedy's responsible for not just the technology but also the avionics. The high schools are doing the integration of that into the field for testing at the test site. But in addition to that, they're building the flight frame that will enclose the electric dust shield. And so they've got some amazing technologies at the high schools, including a water jet cutter at one of the high schools. It's not the same wood and metal shop work that we did when we went to junior high. And so we're working very closely to make sure that the flight hardware they build is consistent with NASA standards, and that's part of this mentoring that NASA is providing. So again, thanks for letting me come and share with you the exciting opportunity of MoonRIDERS.